1.
Okay, we want to continue today and finish up binomial distribution. And what I want to do is jump in with a typical example that's going to ask several different questions. So, here we go. If 30% of the people in the community use the library, if 30% of the people use the library, of the people in the community use the library. Find these probabilities for a random sample of 15 people. Okay, and I'm going to ask you several questions. The first question is the probability exactly 7 use the library. So question number 1, exactly 7 use the library. Okay? Now, if you go back in your notes from last lecture, we have this binomial distribution probability formula. And you can utilize that formula, right? So that's one way you could attack this problem. A couple of things. What would n be? What would p be? What would x be for this particular setup? N is 15. P is
7 out of 15?
What's the probability that a single person uses the library? 0.30, right?
Well,
That's the percentage given. I didn't write Q, but what would Q be? 0.7, right? And we're asking exactly what in this problem? 7. Okay? So you could certainly go into your notes and you could fill this in and you would get the answer that way. Okay? Option number 2 is to go to your table in your book, right? And find where n is 15, where p is 0.3, where x is 7, and you can look that number from your chart. Okay? Today we're going to look at attacking this problem utilizing technology. So we want to look at the calculator function to do it. And also you've already started a little bit with Excel, and we're going to continue with Excel. Okay? So what I want you to do today first is use your calculator. Okay? So go to that spot I just had you go to, where we have Binomcdf. And your syntax is n, p, x. Okay? So to solve a problem, you're going to go to Binomcdf, and then a parentheses opens, and then n here is 15, so type 15, then hit your comma key. Okay? Then your p is 0.30, so 0.3. Then again hit your comma key, and then hit 7, and then close parentheses. Okay?
Where's the comma key?
So let's all do that, and then we'll double check this answer. If I round to 4 decimal places, 0811. Okay, and that's all there is to it. So the reason why I'm introducing technology today is because a problem like this we wouldn't necessarily have to use it. Okay, but as we get a little bit more and more complicated with what we're asking, it's going to be very helpful to understand this. Okay, let's go to question number 2. Instead of exactly 7 use the library, how about at most 7 use the library? So no longer exactly 7. Question 2 is at most 7. Okay, so the first thing that we need to know is, what does at most 7 mean? What could be true if we're saying at most 7? Could have 0 people use it, 1 people use it, 2, 3, 4, 5, 6, at most 7. Okay? So how would I do this before today? I would go to my chart and I'd have to do probability of 0 plus the probability of 1 plus the probability of 2 all the way up to and including probability of 7. This is what we mean by at most 7. Okay? It could be 0 all the way up through 7. So you could certainly do that and go through this thing a bunch of times and put, NP0, NP1, NP2, and add those up. But luckily for us, we have a quicker way to do that, and instead of Binomcdf, you use the cumulative function, Binomcdf. Okay? So when you use the Binomcdf function, that adds for you all the way from 0 up to whatever number you put in. Okay? That's how it works. So to solve this problem, I want to add from 0 all the way up to 7. So I'm going to put 15.3, 7. Okay? So that last number is very important. It's going to add the probability of 0 plus the probability of 1 plus the probability all the way up to whatever number you put in there. Okay? So let's do that. So go to distribution, go down to Binomcdf, and then do 15, 0.3, 7, and you'll see that that comes out to a much higher percentage, right? It's not a single probability, it's all the way from 0 to 7. So it's 9499, so round that up, 950 approximately. Okay? All right, great. Question number 3. How would you do at least 5? At least 5 use a lever. So now we have to form a strategy. Okay? I've given you one key that will give you exactly. I've given you one key that will give you 0 up to whatever number. All right? What is at least 5? Just in English terms, what is at least 5? It could be 5 or more, right? 5, 6, 7, 8. How many people are we looking at? 15. So at least 5 in this problem means 5, 6, 7, 8, all the way up to 15. Is everybody with me on that? What is the quickest way to get this answer? Well, let's look at this. We have 0, 1, 2, 3, and 4, 5, 6, 7, 8, 9. If we did the probability of all of these and added them all up, what would that have to equal if it's a probability distribution? 1. Okay? So I have to use my smarts here. What I can do is I can do 0 through 4 with my Binomcdf function.
So like an at most.
Well, at least 5 is 5 through 15.
Right. We can do
so
at
I'm going
most
to do the opposite.
0 to 4.
0 through 4.
We'll take the
And then what
opposite.
would I have to do to get the answer then?
Get the complement of that.
Do the complement of this, right? So 1 minus Binomcdf 0 through 4. Does everybody see that? Because I want 5 through 15. What I can get is 0 through 4, and then just do 1 minus that. Okay? So let's try that. So we're going to do 1 minus Binomcdf 0 through 4. So that will be 15, 0.3, 4. Again, 4 in the CDF means 0 through 4. Okay? So in your calculator, type 1 minus, then go to your Binomcdf function, then 15, 0.3, 4. And you get approximately 4845. Okay? So far I'm able to do exactly 1, you just use PDF. At most, 0 up to some number, you just use CDF. Okay? If the question is at least, well, we can't really do at least, but we can do the opposite. You can do 0 through whatever, and just subtract that from 1. Okay? All right, next question. Between 2 and 8, use the library. Between 2 and 8. How am I going to do between 2 and 8? Okay, and we talked a little bit about this last class. Between is a tricky word in math. It means literally between, right? So let's think about, what do I want? If I want between 2 and 8, what do I actually want? 3 up to 7, right? These are the probabilities that I want. Okay? How am I going to get this answer?
Use a combination of those two.
Well, I could do 0 through 7 really easy, right? What would give me 0 through 7? CDF will give me 0 up to whatever number you put in, right? But I just want 3 through 7, so I'm going to have to subtract off 0, 1, and 2. Does everybody see that? So to solve this problem, you're going to do a couple of things. You need to know between means between, so we're just doing 3 to 7. You can get 0 to 7 with CDF, and then you're going to subtract off 0 through 2. Okay? So to solve this problem in your calculator, you're going to do Binom CDF. N is still 15, P is still 0.3, and I'm going to do 7. That adds up everything from 0 all the way up to 7. Then I'm going to subtract off Binom CDF. Still N is 15, P is 0.3, and look at what I'm subtracting, 0 through 2, right? So I'm going to do Binom CDF 15.3, 2. Okay? So go ahead and plug that in your calculator, and that will give you the probability that you want, which is 3 through 7. So, same place, distribution. So we have 15, comma, 0.3, comma, 7. Minus, then distribution again, Binom CDF, 15.3 into. And you get 82315, so round it up, so 8232. So approximately 0.8232. Okay? Okay, one more question. The last question is, at least 1, use the library. So tell me how you're going to get at least 1. At least 1. What is at least 1? So 1, 2, 3, 4, all the way up to 15, right? So at least 1 is x is greater than or equal to 1. So 1 all the way up to 15. All right, how am I going to get that, though? Will my calculator do from 1 to 15? No. What will it do? 0 to 15. I don't want 0, so what do I have to do?
1 minus the probability of 0, right?
Yeah, 1 minus probability of 0. Does everybody see that? So to get 1 through 15, I can't do that. I can do 0 through 15, which is everything, and then subtract 0. Okay? So we want to do 1 minus the probability of 0. All right? So you're going to do 1 minus. If I'm just doing 1, can I use CDF or PDF? Which one can I use?
PDF.
Yeah, you can use PDF because you're just doing 1. Technically, you could use CD2 because you're starting at 0 and going up to 0, but 15.30. Okay? So in your calculator, to get this one, you're going to do 1 minus Binomcdf 15.30. Turn the complement again. .9953, yes, 0.9953 approximately. Okay? So that is pretty much every possibility that you're going to face using your calculator. Okay? Great. Let's still stick with this problem, but now let's take a look at using Microsoft Excel. Okay? And you've already started using it. Okay, in Microsoft Excel, what is the function for binomial distribution? It's equals Binomcdf. Okay, then there's a parentheses, right? And then what happens? What do you put in first?
Address bar.
Yeah, so X, the number of games that we're looking at that we want, right? Comma, then N, right? The total number, I think you guys are doing football games, right? Total number of games played. Then P, the probability of success. And then the most important thing here is in this last, you're doing false or true. Okay? So just like we did with the calculator with PDF, when you're just doing one, you use false. Okay? So false is the same thing as a calculator PDF. Okay? If you use true in Microsoft Excel, that's the same thing as a calculator doing a CDF. It's doing a cumulative from 0 up to whatever number you put in. Okay? So in lab, I believe 6, you're pretty much doing false for all of them. Okay? However, lab 7, which is a much more difficult lab, you're going to have to do what we were just doing. When do I do true? When do I do 1 minus? Blah, blah, blah. Okay? So let's do a problem or two with the same setup using Microsoft Excel. Okay. Let's say example 1, I want at least 5 used in library. Okay? So if I want the probability of at 5 using the library, using Microsoft Excel, again, think about what this is telling you. At least 5 is 5 through 15. All right? So just like with the calculator, you can do 5 through 15 by using the complement. So what we'll do is we'll do 0 through 4, and then we'll subtract that off. Okay? All right, so in Excel, what you would do is you would do equals 1 minus Binomial Dist. So 0 through 15 is everything, so I have everything, but then I want to subtract off 0 through 4. Okay, so 1 minus Binomial Dist, 4. How many games do you guys play? 11 or 12? 12. Okay. And then, oh wait, I'm doing a different problem though. Doing this library problem. 15, P is 0.3, and then true, because you're doing CDF. Okay, does that make sense? So when you guys get to your lab, you have to finesse and decide what part we're looking for. Okay? Double check all of your lab questions using your PDF and CDF that we did with the calculator. All right? Let's do one more. How about between 2 and 10? How would you do between 2 and 10?
We do 0 through 10. We would subtract 0 through 2. No, we would do yeah.
Okay, yeah. So be careful. Between 2 and 10 is actually really 3 through 9.
Oh, so we don't do 0. We do 3 through 9.
So you'll do 0 through 9, and then you'll subtract 0 through 2.
Right.
Yeah. Okay. Does everybody see that? So 3 through 9 is what I want. I can do 0 through 9, and then I'll have to subtract 0 through 2. We'll take that away. Okay? So you'll do binomial distribution 9, okay? Then minus binomial distribution 2. Okay? So the formula would look like equals binomial dist 9, 15, 0.3 true minus binom dist to 15.3 true. Okay? So this next lab is kind of difficult. You really have to figure out what you want, how to get that, what you need to subtract off. Okay? Because binom dist 9 true gives me 0 up through 9. So I have to subtract 0 through 2 because I don't want that in my answer. So binom dist 2 true, that subtracts 0 through 2. Okay? So that's binomial distribution with your TI calculator and with Microsoft Excel. Any questions on that? All right.